All right. I got a green light. I got a green light. No? You want to come up and turn it on, Bill? No volume yet? You want to go to the other one? Hello, hello, hello. Direction for our church. We appreciate your prayer and giving us wisdom and seeking that. It's very important for where we are going to go in the future. Also, I'd like to remind you that you can come early to the church mornings at 9 o'clock and prayer room in the back and pray for the service. I have a little side announcement here. In order to have something stick in your mind, you have to have some object lesson. You can't see, but you can see my socks. And on those socks it says, feed me. Now this little anecdote I'm going to relate to you has nothing to do with me, I'm sure you. As Paul said in Ephesians 3, he's given us, each one of us, a gift. And you can see the gifts that we have with Emily and the rest of the group here. They are using their gift. We all have a gift, every one of us. And are we using that gift? Now, this little anecdote, it's got nothing to do with me, as I said. This fellow tried to take it a little further than you would normally think. A wife asked her husband to set the dinner table. But inspired by the pastor's recent message, he said, "Sorry, dear, that's not my spiritual gift." She asked what his spiritual gift was, and he nonchalantly said, "Eating." And he said, "Oh." She said, "Well, if you want to exercise your spiritual gift, you better set the table." And that applies to each one of us in which circumstance that we have is how do we use our gift, not for our benefit, but for God's benefit. And we have a guest speaker again today that is using his gifts on creation. And this message that he's going to bring this morning is the second part of the flood of Noah. And I would like to welcome Greg back and we'll listen to what he has to say again this morning. Thank you.
Yeah, I'm just going to move that stand a little bit here. Just back this up a tad. That's in case I get wild and I want to run around and I've got no room left. First of all, make sure everything here works. The usual. You got sound. I got that there. Well, welcome everyone. I see actually some of you showed up even after last week's message. Well, cheer up. It's only going to get more challenging. All right? And to say I've used to do this actually generally in 3 parts, so obviously I'm going to compress a lot. You can talk about this for a long time because there's so much mixture of between trying to say, what Scripture tells us and then what might have actually happened in terms of the physical changes that occurred within a great flood like Genesis flood. When I do this, though, we always put this in the context of Scripture in the big picture. And I showed you this last time. This is the quick review. We call it the 7 C's of history, biblical history. We start with a creation of a perfect created world. We end up with, of course, the disobedience of Adam and Eve that led to the curse. And just as an anecdote, when we look around us, and we often still say, oh, how beautiful the creation is and how beautiful it is and speaks of God. Can you imagine we're looking at something that's marred and still looks so good, right? And yet what has happened, we'll see even during the flood, it basically tore the earth's surface apart. And what we see now is a rebuild. But that's how good God is. He can take something that's destroyed and rebuild it, and it still looks darn good. And I'm thinking we're talking about you and I, right, through salvation. So anyhow, we end up with the corruption and then catastrophe. That's what we talked about and started last week for Noah's flood. We have the Tower of Babel and the confusion of languages, major event. The establishment of the Old Covenant through Abraham. The establishment, of course, a new covenant through Christ. And lastly, a consummation which will be the perfect restoration of what we see. The curse will be gone, and we will see a new heavens and a new earth, and man, it's going to be something. Because if this is anything like a marred one is, I want to see what the perfect one looks like. And we look forward to that. We also then tried to put a time frame, a biblical time frame, to when this flood would have happened. And this is an abbreviated version, remember, of that timeline I had, where if you start from creation point of the 7 days of creation, these show some of the major individuals, and you'll notice, first of all, how long they lived. We had Adam. He lived 930 years according to the genealogies. He intersected with many others, children, grandchildren, and so on. But I'm just showing Lamech, who lived then to 1651 years after the flood, and then Noah. Isn't it interesting that even from the time of Adam, there wasn't much time between Adam's death and Noah's birth, because he lived so long. And we believe this is what actually was true. This is true. We don't sort of try to mythologize it or anything like that. God created perfect human beings. They were meant to live forever. So now we see them actually reduced in lifetime. But you'll notice that then when Noah comes along, it says in the 600th year of Noah's life, that's when the flood happened. And you'll see that he intersects with Terah and almost with Abraham. Now, based on that, we can put the flood at 1656 years after the creation of the world. Okay, so we can target that. I believe in a earth that's a biblical time frame, I call it, where it's some say it's a young earth. Well, we can know roughly in history when Abraham existed. So it doesn't take a lot of math to then extrapolate backward the number of years back to Abraham using genealogies. So we end up with this ballpark of 6,000 years. So the flood then, in our biblical time frame, would be roughly 4,500 years ago when it would have occurred. We then moved on, and this is the fun one too, right, where we see these little animal caricatures of an ark with these animals stuffed into them, and it's quite a bit more complex than, of course, what that little picture shows, because they would say, well, isn't that silly? How could we get all those animals on the ark? So we spent quite a bit of time, and I had to get into the biology, right, where we talked about created kinds. When God made the animals and the plants, he created them after their kind. And it says they will reproduce after their kind. So that kind we would see is not necessarily what we see in species today. They would have been a cross hybridization and so on. It's complex. But we talked about dogs and the variations within dogs, but they're still all dogs and they're dog kind. We can have cat kind. We can have dinosaur kinds. So when you look at Genesis, there's a number of places where it's worded like this. Chapter 1 in the creation account. God created the great sea monsters and every living creature that moves, with which the waters swarmed after their kind, and every winged bird after its kind, and God saw that it was good. And it says that in a number of different cases. So that's where we started saying, well then, how many animals need to be on the ark, and could a practical ark be built big enough? Well, first of all, plants, insects, sea creatures don't need to be taken on the ark. I think that eliminates like species-wise, we call it, every little variation possible, maybe up to 1 million species right there alone, because there's way less on the land that actually took in air, because that's what it said. Only the one that breathed in air through nostrils really were the ones that needed to be taken on the ark. Okay, so they did calculations. They feel that an absolute maximum of 8,000 genre, that includes extinct animals, so maybe 16,000 animals. Recent studies, of course, because we see that the kinds were much more genetically rich than we were originally presuming, therefore they could vary far more within the kind, and therefore they put the number at maybe even 4,000 animals. Remember, they're not all big dinosaurs, so you have the medium animal sizes around a rooster or a small rat. So you see then that if you take the dinosaurs, because everybody asked what about the dinosaurs, and I said, well, you're not going to take the full-grown Apatosaurus. I'm sure when God drew the animals to the ark, which he did, that's what the Bible says, he would have taken the younger juvenile ones, probably because they would, be more able to survive after the flood as well. Turns out they had a bit of trouble because the conditions got harsh after the flood. It was called the Ice Age. Well, when we looked at the ark dimensions, if we assumed a cubit length of 18 inches, usually from here to here roughly, we got a 440-foot long vessel, 74 feet wide, and a height of 44 feet, or roughly 4 stories. We did the volume. This was calculated out. It's about the equivalent of 522 railway stock cars in volume. Each box car can hold 240 sheep, which is quite a bit larger than, of course, the average rat size. Total capacity then of the ark would be about 125,000 sheep. We have 16,000 animals that we need maximum, so therefore it takes up about 14.4 boxcars. That's about 2.8% of total volume. And they did calculations then on did they need to take drinking water, but of course there was a lot of water coming at first, so that wouldn't have been an issue at first. But we needed food. Did God put them in hibernation states? He could have done that. There's a lot of aspects here, but they're trying to even account for it even without much supernatural intervention in the animals. So there's a lot I could have even said on there, but I gotta hide that. Yeah. I was looking for somebody that was maybe new here, and I'm not seeing anybody, I don't think. Anyhow, geology in church. I feel guilty. I said it last time. I actually kind of get this little guilt thing going on here. I'm not used to church being this way. But I like now, my favorite guy to quote is Johann Kepler. He's the famous astronomer that studied, about the planetary motions and so on. A full-blown Christian, and he said, science to him was honoring God after his thoughts. So even when we look, and here I speak about science, I always loved science. I did, always. And yet it became even more poignant to me when I met Jesus. And I started seeing things in a different light. And that science to me was still like, wow, God, you're awesome. I could get into a complexity discussion and talk about how great the creation is, and you and I, how complex we are, how great that creator is. But we're talking about a flood. Well, do we have evidence for a flood? It's got to cover the whole earth. Sorry, folks, I'm going to say right off the hop, it can't be probably a little calm flood. It ain't going to work that way. So it's going to be major catastrophic event. And so based on that, let's go back. I'm going to ask you a question, and you don't have to give me the answer here. Where was the Garden of Eden located? Multiple choice. Number 1, Australia, America, in the area around the present Tigris and Euphrates rivers. We can't know. I guess some could say it's not important. I'd never put that one back in a multiple choice question. So there's an interesting question. When you look at a map, you can see around Baghdad and that there's these Tigris and Euphrates rivers that we've named today. That's what they're called. And you go, well, it's probably somewhere in there. So some of you might even have said that, right? Where the nearest Tigris and Euphrates River. Not a bad choice. Except it's interesting. I'm going to just quickly do this. I don't want to waste too much time on it. In Genesis chapter 2, verse 10 to 14, it's interesting when you read through the account of where the garden, the water flowing from the Garden of Eden was. It talks about it's separated into 4 headwaters, and it names 4 rivers. The Pishon, the Gihon, the Tigris, and Euphrates. Guess what? They're not all together on any map we have. And you also got to remember that an interpreter, when he takes the Hebrew, he has to put it into something he knows now. So he will pick Tigris and Euphrates because those are rivers that are around that location. So my basic thing is we probably can't know for sure. We might have the ballpark area. It also shows that you can't think of what was before the flood in terms of geology or geography would be the same as what we see today. It could be dramatically changed. That's why we can see creatures that would normally be in the tropics, they're buried as fossils up in the tropics, up in the Arctic, that kind of stuff. Something's going on here. Well, I also have to say this. Not all science is the same. This is so key, folks, because so many would disagree with what I'm saying up here, whether even some Christians and non-Christians as well. I get that. But I want to be clear. When I took science, because I was a physics dude, primarily, I believed and generally operated in the area of what we call operational science. This is where you get repeatable and testable events. For example, my classic case is in physics, we always did little air tracks. Remember those little carts that moved and they almost frictionless back and forth? See, if you didn't take physics, you missed something great, you know. And these carts go back and forth, and we used it to study Newton's laws. And his second law, which is set as F equals ma in a formula, talks about a relationship. And you know, you could argue with me as a student and say, you know, I don't agree with that. Well, why don't you agree with it? Well, I just don't. Okay, let's go to the lab. We'll set up an experiment, and then we will verify, and we could. Consistently, time after time after time after time, we verified it was true. So, operational science allows us to do that. That's what puts, as we used to say, men on the moon. Good science leads to things that we can test. Question: what about things like the flood, the Big Bang, the evolution of non-life into life? Can we go back and redo those and repeat those in this experiment? Nope, can't do it. So historical science or origin science, being not repeatable or testable, you have to hold it more loosely. You have to. It doesn't mean you can't study it, you can't make inferences, but always a bit of a grain of salt, I call it. All right? Whereas if it's repeatable, testable type science, we can do experiments, that you should hold on to a little more tightly. Because gravity is pretty well attested to. Is it possible there's a pocket of God created out there that suddenly gravity doesn't work? Well, we don't know that. All we know is on Earth and all that, it does work. It's there. All right, here's a quote from Barbara Kay, and it's titled 160 Years into Darwinism. There's one mystery we still can't explain. You're saying, well, what's this got to do with this? Well, let's see what happens. This happened in the National Post. She posted it in 2019. Okay, quote, "Back when the world was young, I was taught that 4 visionaries' theories shaped modernity. Charles Darwin, hold on one, Karl Marx, Sigmund Freud, and Albert Einstein. Of them, only Einstein could be subjected to scientific scrutiny. The rest remained hypotheses, resistant to such standard scientific tests as falsifiability, replicability, and predictability." Say those fast 3 times. Well, but so beautiful in their comprehensiveness that the intelligentsia, the smart dudes, accepted them for what they were not, settled science. Woo! National Post. In other words, you got to hold Einstein's theories a little more tightly to you than you might Charles Darwin, because you can't go back and redo it. All right. How about future science? Got to throw this in there, especially with all the climate change talk and stuff going on. There's a sign up on Glacier National Park called "Goodbye to the Glaciers." And it talks about, I can read it for you, the small alpine glaciers present today started forming about 7,000 years ago and reached their maximum in size and number around 1850 at the end of the Little Ice Age. They are now rapidly shrinking due to human-caused climate change. Computer models indicate the glaciers will all be gone by the year 2020. Okay, you read that and you go, ooh. Now, of course, we can get evidence still. So how about a picture that compares 1910 to 2020 of Jackson Glacier? Is Jackson Glacier gone in 2020? Picture on the side, the color one. No. Is it smaller? Yes. So you see, when you try to predict something, even like in the future, you got to hold it sometimes a little bit loosely. All right? Now, in terms of the Bible, we have certain models that can try to predict and say, how could all this water cover the whole Earth? Well, remember, we do have 70% of our planet is covered in water. If you flattened all the land surfaces out, you know how deep it would be? I think it's like 1.5 miles deep. It would cover the whole Earth. Now, it's very interesting. They believe there was major flood events on Mars. Major. They believe it was once covered by up to 60% water, liquid water. You know what? You can't find one drop of liquid water on it right now. So they say, well, now they're thinking maybe it was 7 to 12 miles down, embedded in rock. So you see, their theory, in their brain, they're allowing themselves to say, well, it's okay to have 60 to 70% of Mars covered in water because of the canals they see and different types of erosional features. It's interesting, when it comes to the biblical model of the flood, they don't want it. They don't even think about it as possible. Okay, what about Christians? Well, here's what I say. Hold the models loosely and the Bible tightly. Because the Bible is something that is inspired by God. He's the observer. He was there. That's what I'm going to start with. So that's called an axiom. That's called a beginning point. So therefore, even when creationists come up with models, you should hold them loosely. That's including what I will tell you now. Is it possible? Yes. It might have good explanatory features and so on. Hold on to them. Well, they had things like the water canopy, vapor canopy theory. A lot of you might have known this one. And they believed there was this canopy of water that encircled the globe, a vapor, And the trouble with us, as they did analysis, first of all, there's not enough water to flood things. Secondly, it would make the earth unbearably hot because it's the best greenhouse gas there is water vapor. So basically gone now. They just think it's not possible. Hydroplate is closer. Dr. Walter Brown did this one. And he quote, before the global flood, considerable water was under the Earth's crust. Pressure increases in the subterranean water ruptured the crust, breaking it into plates. The escaping water flooded the Earth. Okay, that was held for a while. Maybe there's a version of that. Probably the most common one accepted now is called CPT, catastrophic plate tectonics. You see, right away, what have we got a problem with? Catastrophic, we know the word. Plate tectonics? How many here are familiar with plate tectonics? Honest. So therefore, by the show of hands, you need a geology lesson. Because otherwise, if I wanted you to do an apologetic, and somebody asked, well, where did that water come from? Where did it go? Well, you need an apologetic if you want to try to answer it. So therefore, how about a little geology? It's not that hard, okay? It's geology. Sorry, folks in geology. Not as hard as physics, no. All right, there was a team that did this back a while ago now, headed by Dr. John Baumgartner, and they did a lot of research on this because they realized we needed a better biblical model for the flood. Well, in order to understand this, we have to go back a bit in time. There was a hypothesis developed in 1900s by Alfred Wegener, and he proposed that all land masses were originally united into a single supercontinent. He named it Pangaea. And therefore, he believed that original global supercontinent broke apart and became what we know in the Earth structures today. And even as Christians, we might be okay with the idea of a supercontinent, because in day 3 of creation, what did God say? He said that he separated the waters from the land, and he created the dry land. In other words, he separated them. So maybe that it wasn't like we see today. No North America, South America, Africa, like divided up. One land mass is good. We're okay with that. Now, they've modernized this a bit, and it's called plate tectonic theory. And this theory postulates that the Earth consists of numerous variable-sized pieces called plates. These plates on the Earth's surface vary in thickness from 100 kilometers to 250 kilometers thick. Now we see, for example, I gave an example. I can't use the pointer on a screen anymore. It works good on a projector screen, but you see a laser doesn't show up very well on a TV screen. Darn, lost something there. Now, you can see on that picture over there, if you've got good eyes, it's called the Mid-Atlantic Rift. And it's a plate where actually something's moving apart. The ocean crust is moving apart, and magma is coming up in between. Now, they've been able to then classify and look throughout the Earth, and you won't see the details, but you might get the idea. Here's a global map, and it shows all the plates that they believe exist now, these rigid, roughly rigid plates. Then they also found that they're moving a bit. They move on average, I think I have it a little later, from 5 to 10 centimeters. If you could see carefully on this graph, sorry about it, but I'll explain it again. There's places where you will see little arrows. Some of them are going together like this. That means the two plates are colliding. When they collide, it's either going to do one of two things. It'll either push together or it'll what they call subduct. And it says the movement up there by Alaska is roughly 6.9 centimeters per year. Okay, roughly. Some places, like the Mid-Atlantic one, they show arrows going the opposite direction. That means the plates are moving apart, in this case at 3 centimeters per year. And magma comes up in between. Then the last type is the San Andreas as an example. It's up near California there. You'll see it says 5.5 centimeters. They're moving this way, which is interesting, right? So they're subsiding this way. So we have what types? We have collision, which can cause either uplift or this way, or we can have separation, or we have lateral movements. So those are the basic classifications. When they do, by the way, infrared, they can see the hot spots. In a lot of cases where there's a lot of volcanic activity subterranean in the waters. Well, okay, so when they have pictures in textbooks, you'll often see things like this for what we believe the Earth looks like inside. We've got a very hot inner core, an outer core, a mantle, and then there's the whole area called the asthenosphere, the lithosphere, and so on. And this is where, of course, most of the action takes place, is near the surface. And so they show different pictures there. For example, a trench of subduction. That's an important one, by the way. I should almost point that one out if I could. Sorry, guys. It's showing right over there that the Earth is, that plate right there. They show it driving under. It's where some of the ocean plane is still driving under the one before it. All right. Well, how do we account for this stuff? Well, if the rates are 2 to 15 centimeters per year, and here's showing, sort of speeded up idea, well, they would extrapolate that number into the past and say, see, it would take, tens of millions of years for the Atlantic Ocean to form as, it splits apart the continent plates. And so you go, okay, that's, a bit of a justification for them, because they're saying, if we take today's rates, it takes a long time to form stuff. Now, but to be fair, this is from the Historical Geology book, 4th edition, so it's a textbook. When they look at what's the driving mechanism for the plates, what's pushing them? Whole continent areas are moving. Well, basically they say almost most geologists agree that Earth's internal heat plays an important role in plate movement. There are problems with both models. Thank you very much. I actually appreciate that. In other words, it's not a slam dunk. Okay, back to our issue. What would the conditions look like prior to the flood? Well, we believe there was indeed one landmass, a supercontinent. Because why? Because it looks like things were fitted back together at one time. That's legitimate. There's a fit. I guess if you even take the ocean, the ocean shelves off the coasts of the continents, if you put those into play, then they actually fit very, very well. Well, the mountains were probably not as high. And you're saying, what? Well, because we're going to see that the forces that would cause massive mountain movements were these plate movements that occurred big time fast. All right? We have oceans that are not as deep. This also relates to one of the Psalms that I'll quote later. We have, of course, that there was massive underground water reservoirs. We still believe that is true. So even secularists will put in supercontinents called Rodinia. Some say that in creation circles that Rodinia breaks apart and temporarily forms Pangaea, and then of course eventually into the continents we have today. Don't get mixed up with that too much, it's whatever. So they have things like Gondwana and so on. But you see in the beginning of the flood, what does it tell us? From Genesis chapter 7 verse 11. The same day were all the fountains of the great deep broken up, and the windows of heaven are opened. That suggests something from the deep and something from the heavens. What would have caused Noah's flood, triggering it? We don't know. Could it have been a meteor impact? Maybe what they call the late heavy bombardment, where they see a lot of asteroids or meteorites that struck planetary surfaces, especially the inner planets, like even the moon and so on, could have been. Maybe it was just triggered by God. Right? Now, I made up a hokey little picture here, and this is all done by me, so cut slack. I didn't get paid a lot as a person who's big into graphics to be able to create this. Can you see it, I hope? Here's the basic idea. Got explained a few times. We believe that there was the original ocean plate was, of course, denser than the mantle materials below it. which is common, the rock there. So it literally kind of floated on top of the mantle. We also have the continental plates. Well, what happened was, whatever caused it, these started to fracture. So for example, I'll put what's called a fissure at one place in one of the ocean plates. Something causes it to fissure. Well, when it does that, guess what? It creates an opening through to the hot mantle and magma that's below it. That magma would heat the waters so fast and so hard that it would create supersonic steam jets that would fly into the atmosphere, water vapor. And here's sort of a quick little graphic-y of that possibility. I'll show you a better video and it'll sort of show this happening. So this is catastrophic plate tectonics. In other words, things are going to happen quickly. Most of what we see on the movement of the creation of all the continents would have happened in basically under a year. Not 50 million years, under 1 year, because that's Noah's floods time. So there's a big difference in these two models in terms of speed. So how could this happen quickly? This is where it got interesting. They did computer models of this and so on, creationists, and they found out that if you actually started to have a subduction event, like that's what that one's showing, here's the continent and then the one starting to subduct, the ocean plate going underneath, it's hot. And what happens when you make something like that hot? It gets, right, the viscosity changes. It gets more fluid, and therefore it can slip faster. So that's what they believed. It was destabilized, and once it started to go under, it went quick. Matter of fact, it accelerated, because the more it went under, the more friction there was as the continents are moving by each other, and the hotter it would get. So this would, of course, as it sank, would produce what we call a mantle convection. That's what I'm showing in the arrows. Well, it would also then have a tendency to start pushing up on other ends of the plates. It's that push up as one factor that pushes up on the water. So as it pushes up in the water, that water level is starting to change higher. Do we have to cover Mount Everest? Not necessarily, right? Because we said Mount Everest is something we see today, not necessarily what was in the past. So maybe we didn't have to cover 29,000 feet of water. All right. As it went through, of course, so I got some magma, right? Because magma goes through that fixture, starts, like lava, boiling up in there. What does it do? Heats the oceans. But it also, as it expands, what's it going to do? It's also going to increase in amount and cause and you get what we call runaway subduction. It's just accelerating like a conveyor belt. And it's pulling the old ocean plates down into the mantle. It's just doing it very quickly. I'm trying to make this, roughly palatable. Okay, and as it does this, what would it do? Eventually it gets high enough that it will be able to cover all the high mountains, and so the whole earth would be covered. By the way, there's actually possible evidence for these ocean plates that existed before the flood down near the inner core. They do this through using earthquake analysis and so on, and here's actually what they believe are ocean floor slabs in the lower mantle of the earth, still undissolved. So it couldn't happen 50, 100 million years ago. They're still cold enough to exist. Here's another picture. By the way, there's even more recent evidence, came up just the other day, I read it, and I won't get into that even more and more verifies that these plates exist down there. All right. When they did models, by the way, how fast this happens, now you're not going to see this again. It's actually, you can see little shapes of maybe, that's why you sit in the front, right, Eric? You can see maybe South America and Africa and so all joined together, and they show how these happen. So they globally model how fast does it happen. The rates of spread were up to 1.7 meters a second. Okay, so that far, the land moves that fast in a second. So therefore, there's a bit of spread in the continent starting to form. Sorry about this online, but maybe you got it online there. For example, there is the Atlantic Ocean starting to form right there, that little gap from there to there. Well, guess what? This is put on day 15. Okay, the next one actually shows it in day 25. So 10 days later, it's now that far apart. That's 1,000 miles apart, because you're moving it at 1.5 meters per second. So this model, of course, has been refined and so on. It's the best model we have at this point. Okay, you're going to hold the model loosely, right? And the Bible tightly. All right. How about this? Let's look at some. There's the supercontinent in the center, and then the floodwaters are starting to be pushed up from the ocean. There's the So what do we have? Continental sprint. That's what we like to call it, right? Oops, let me see. I think this thing actually was an animation there, wasn't it? Yeah, there he goes. So we call it continental sprint. Okay, evidence. We need more evidence. What is there today that might point to the correctness of this model? Well, first of all, during the flood, we would see the water as a powerful force, hydrodynamic sorting of sedimentary particles along with plants and animals. That's what would produce the multiple layers. The animals are buried quickly and fast. Fossils would form in the billions. Guess what? We see fossils formed in billions. I always get a kick out of, you know that there's marine fossils on the top of Mount Everest. Now they say that it was 50 million years ago that it was underwater and then it rose up and they were there. Well, okay, that's their explanation. We also see things like in the Burgess Shale in near Banff, right, and so on. That's high up, and those are all marine creatures. Buried in the billions, literally. Massively buried quickly, suddenly, because you don't form fossils if you don't bury them quick. They get eaten, scavenged, and they decay. So we have this layering. Now they have interpreted what I'll call the uniformitarians. I'll explain that in a moment. They call it the geologic column, and attached to it is the geologic timescale. They put the events of the first creatures on Earth roughly 500 million years ago. That's called the Cambrian. Matter of fact, they say it happened as an explosion of life, the Cambrian explosion. And therefore you will see in this little diagram that as we move up, we get to more and more, I hate to use the word complex creatures because even the ones below are very complex, but you'll see there's a burial order, a rough burial order. We say, well, we can account for that through what would happen where they live. It's called where they live in their ecosystems. See, when the water starts coming up in the mud, it's the ocean floor near the continental shelf, the creatures there are going to be the first to be buried. So they'll be the ones that look like at the bottom of this picture. Then we're going to get more near the shoreline. What are we going to get? Well, we're going to get more of the fishes, and then eventually, if it gets up in the water, we're going to get the reptiles and so on. You see what I'm saying? And where will the mammals more likely be? Further inland. So there's an order. Yes, we expect an order with a lot of, mumble and jumble around type of thing going on. Matter of fact, creationists then have said, well, we'll take the rock record and use some of the same terms that they, the secularists use. That's why you see the little column on the side, and you'll see Precambrian. Well, that's before the flood. So we believe the layer above that was caused basically from the flood. I sort of go through this. I'll just do it quickly. Well, before the flood happened and God created, first we see created rocks without any fossils in them, deep down in the rock. Okay. What else do we see? Well, second, we see miles of sediments without animal or plant fossils formed on the edge of continents as they rose out of the water on day 3 of creation week. That's when he separated the land from the waters. Okay. Thirdly, we see sediments and reefs that built up between creation and the flood. How long? 1,656 years of time. Then we start to see the thick, uniform sediments laid down by water and full of fossils, spread across continents thousands of feet above present sea level. And these rocks is also evidence of rapid splitting and collision of continents. Okay, how you doing? Fifth, we find sediments full of fossils formed in the catastrophe that decreased in size as the earth crust stabilized and the climate cooled and dried and animals and plants refilled the earth. And then lastly, of course, we have the modern era more. We encounter evidence of a brief ice age period, the final transition to the modern era. See, that's how we've classified them, because we recognize there is a pattern, but we have a different explanation. Now, this one here, don't know if I should do it or just go on. By the way, there's creationists who've taken creation week, for example, and they've broken it up into different stages. Then they have what's called the antediluvial period between then and the flood. Then they show the deluge or the flood, and they break it up. This is maybe a good one to have. You notice there's two big things called the deluge, and they break it into recessive and inundary. Because inundary is what? Where water gets pushed up onto the continents, and then as the continents change and jostled, the water comes back off. That's recessive. Maybe I will, what the heck. On the recessive side, I've noticed there's two major type of land features that are out there. There are flat, what they call planation surfaces. How many people have seen around Grand Canyon on the top, Colorado Plateau, even some of the prairies in Canada? These are like flat like a pancake. What process could make something flat like a pancake like that? Because when you have rain and water, it makes gullies, small rivulets and rivers, right? So we believe that when the floodwaters were first coming off, they were coming off in vast sheets of water, scarring the continent at that time, the continental surface, so it makes it flat. But as the water gets down in volume, then we get this area what we call where it channelizes flow, and it actually causes grooves to flow into that continental surface. So when you do this on a massive scale, and by the way, we won't cover that. When we look at the termination of the flood, here's Psalm 104. Maybe there's a clue. The mountains rose, the valleys sank down to the place which you established for them. You set a boundary that they may not pass over, so they will not return to basically flood the earth again. Interesting. The valleys sank, maybe the ocean bottoms, right? The mountains rose. So maybe that's why we think there was no Mount Everest equivalent, right? Even in scripture we have a bit of evidence for that. So you see this idea of water running off, and it produces, at first these flat plains, then eventually it carves it, and you may get things like Grand Canyon features. So what are the results? We see high mountain ranges and deep oceans. We see large planation or flat surfaces formed as water flowed off of the continents in sheets. We see deep canyons were produced by channelized water flow. I love this one now. I've paid attention on small scale. I've often wondered, how do you get on the sides of rivers and so on, cliffs are like this, vertical? Because when I always think of it, when water flows off, it always erodes it, it crumbles, and it produces gullies and all that, but it certainly doesn't make this. Well, maybe you're probably much more intelligent than I am, and you figured out, well, I've watched water now, when it flows rapidly in large volumes, it will cut into sediment at the bottom, and it'll eventually break it away, and whole chunks will fall off, leaving a nice vertical side. So maybe when you look at Grand Canyon, when you see some of the major vertical walls, you're talking a lot of water, not the Colorado River. This had to be something far greater than the Colorado River. They say it's the Colorado River over tens of millions of years. And we say, nope, it was a lot of water in a short period of time. Unfortunately, I don't have time to get to all that one. That's my next session 3. Okay, so we get miles thick sedimentary layers filled with billions of fossils. We expect that from this global flood. So you see things like the Grand Canyon. All right, here's a nice little one that I get to have a drink. That's one reason I like having videos here, so I get to have a bit of tea. This is from Flood Geology, and it talks about these rock layers. So if you don't mind, just hang on, right? Can you go through this and you're still good to go? All right, rock layers? All right.
Rock layers are visible in mountains, plateaus, and canyons all over the world. Where did these rock layers come from? Present processes aren't the answer. Today, sand and mud are usually deposited in thin layers along the outer edge of continents, and the formation of fossils today is rare. But somehow in the past, thick layers of sand and mud were spread across entire continents and filled with well-preserved fossils. Noah's flood suggests a way to explain these puzzling features. Flooding the continents, for example, could carry sea creatures many hundreds of feet above present sea level. Andrew Snell is a PhD geologist from Australia who has spent over 30 years studying rocks, working in the field and in the lab.
We find marine creatures buried at the top of the Grand Canyon, which is over a mile above sea level.
A global flood could carry sand and mud enormous distances.
Some of the sand grains that are in the Navajo sandstone had to have come from the Appalachians. But what river or what process today is carrying material from the Appalachians to the southwest?
A global flood could quickly lay down thick layers of mud and sand, burying even giant animals and tall trees.
We've got coal beds with trees sitting on them, and these trees, tree stumps, go through many strata, which means that before they could rot, you had to have lots of sand and mud coming in quickly. several places in the Grand Canyon, 4,000 feet of different types of sand and mud and lime have been bent, and they've been bent while they're still soft. Both the bottom layer and the top layer are all bent the same way, which means that the whole sequence of 4,000 feet of sand and mud and lime had to have been laid down very quickly by the waters and then bent very soon afterwards.
A global flood could form thick layers across entire continents.
In the Grand Canyon area, we've got limestone bed, the red wall limestone. The same limestone can be found over here in the eastern United States.
A global flood could cut deeply and widely.
We've got this huge flat surface at the rim of the Grand Canyon, which goes for thousands of square miles, where waters on a great scale of a vast area just swept over it and swept everything clean.
None of these processes, deep, wide erosion, or thick, rapid layering, or continent-wide distribution, or lifting of marine organisms above sea level, or sand carried across continents, occur in the present. Radically different processes are required, such as occurred during Noah's flood.
Okay, one more concept and we'll pull the plug on this. Oh, it almost sounds like water movement. Okay, we have Nicholas Stenhouse, and I showed this before last week. This is in Berkeley, in their berkeley.edu, and it's showed below the website. And these are no friends to biblical geology and flood geology. But it talks about Nicholas Stenhouse, and it talked about Stenhouse law. And now you might have a little more, awareness of what was he talking about. It should always also be remembered that Stenhouse law in geology is a statement of relative time, not absolute time. Two rock layers in principle could have formed millions of years apart or a few hours or days apart. Now you get why I put this one last time, right? Because Stenhouse himself, he saw no difficulty in attributing the formation of most rocks to the flood mentioned in the Bible. What changed? Because up to roughly the 1600s, in this time, basically they were called scriptural geologists. They almost all hold the various versions of the flood and so on and what the Bible's account was true. Something changed. This is key because it affects how we think. Well, James Hutton starts to give us a clue. He's one of the first geology guys back in 1726 to 1797. So notice he was after the time of Nicholas Stenhouse. And he says, the past history of our globe must be explained by what can be seen to be happening now. No powers are to be employed that are not natural to the globe, no action to be admitted except those on which we know the principle. What are you doing right away? You're eliminating, first of all, the possibility of supernatural, right? Because remember, the past history of our globe must be explained by natural causes only. Well, you're already drawn a line in the sand that eliminates a whole other possible explanation. Why? Well, I think it comes down even further. Here's a quote that might highlight. I don't know if any of you remember Charles Lyell, another one of those big geology guys back in the time, close to the time of Darwin now. This is what Lyell wrote on the 14th June 1830 in a letter to George Scrope, whatever his name is. Quote, I am sure you may get into the QR, which is Quarterly Review, what will free the science, referring to geology, from Moses. For if treated seriously, the church party are quite prepared for it. So they made erosions. Even the church started to capitulate, I called it, where they said, see, this had to be formed by natural processes over thousands and thousands of years, much longer than the biblical account could have. But what's the motivation? He wanted to free the science of geology from Moses, because Moses wrote the Pentateuch, which includes Genesis. In other words, they wanted to get rid of Christian influence. Personally, that's the bottom line to me. Sorry, that's a big generalizing statement. But I believe that's the case, especially in science, because naturalism was their mantra after that. Only natural things. Well, when you look at what I was talking about, how much of that process would maybe need God? You know what I'm saying? Like, weren't we talking about everything was simply geologic processes, physical processes? The only difference was we don't see it happening today. So they got a problem. By the way, they call it the principle of uniformity or uniformitarianism. Okay? And here's how it goes. This is where you extrapolate present processes and process rates into the far distant past. So there's an assumption there. You account for the origin of all things by present process. Applying uniformity leads to inconsistent results. And what I'll say is this: the present is not key to the past, and I might leave it with this quote, or this little video clip. There was more coming, but I'm going to cut it out. It's absolutely essential that the present is not the key to the past. Because how do you account for a catastrophic process that was possible? Well, they'll allow in some small volcanic activity and some small local flooding and tsunamis and so on. But they can't allow the possibility of the global one, right? So therefore, evidence seems to point better, like when you heard that last video, to how do you get that same sandstone in the Appalachians on the east coast, roughly, on the eastern of the United States, all the way over to the Grand Canyon. And it's there across the whole continent, thousands of miles. Same stuff. What river's carrying that, as he said? Doesn't happen. Okay, let's look at this one then. Present is not the key to the past.
When we look at geological features around the world, many of them are radically different from anything being formed today, like thick mud layers over continents, or coal seams covering entire states, or fossil graveyards, or frozen mammoths, or miles of underground cave passages, or thick ice sheets moving over continents, or craters of supervolcanoes, or canyons cut thousands of feet deep. It looks like the present is not the best way to explain the geological features of the past. The Bible, however, offers another way to explain features from the past. Noah's flood was a global judgment, a violent catastrophe upon the earth. Based on this truth revealed in God's Word, scientists are developing a series of models to explain how the flood and its aftermath could have shaped the world today. In the course of the flood, erosion washed away mountains of rock in some places, while miles of mud and sand were piled up in others. The earth's crust was thickened in some places and thinned in others. Like jostled ice cubes sink and bob up to their proper level in the water, some sections of land sank after the flood, while other sections rose. Supervolcanoes and superquakes rocked the world after the flood. As the centuries passed, the catastrophes became rarer and smaller. Modern earthquakes and volcanoes are dim leftovers from this violent period of Earth history. Warm oceans after the flood produced violent weather, possibly even hypercanes, huge hurricanes like the Great Red Spot on Jupiter, which may have persisted for centuries. High rainfall after the flood filled enormous lakes, eroded large canyons, and carved cave systems. As animals left the ark, multiplied and spread over the earth, many of them were preserved as fossils. Some were buried in ash and mud. Some were preserved by unique chemical conditions, and others were frozen. Truly, the present is not the way things were in the past. Instead, the Bible is the key to help us understand geological features around the world.
It's interesting because even now I'm thinking, I should just show this one more. That's one. Okay, hold on, one more thing. Just one more? One more? Okay, quick, okay. Today, and I'm going to really do this one fast. This is an interesting little picture here. You remember Mount St. Helens, right? Most of us do. We're of that age, 1981. We knew exactly when it erupted, how it erupted, and how long it lasted, and so on and so forth. What you are seeing there, and there is a little figure down there, right there in the bottom, that's a person standing there. What you see happened from Mount St. Helens. All the formation of all those layers were from Mount St. Helens. The erosion was from when the Spirit Lake that got dammed up, which was there, suddenly breached. And that water came rushing down and it formed that canyon in hours. So it's not how long you have, It can be how much water, for example, you have, how big the processes are. Here's, by the way, when that one broken down, okay, there's a person standing there. Here's the speed involved. The bottom layer, which was called the airfall tephra, that's the stuff that came out like clouds, that deposit took 9 hours. The center one is 25 feet thick. It's even bedded strata, finely bedded strata. That was when the fast-moving slurry came down, gas-charged slurry, 200 clicks, 200 kilometers an hour, 500 degrees. Wow. How long did it take? It's like within hours, day, not even a day hardly. There we go. The last one, this is more homogeneous mud flow, and this happened in March 19th, 1982, and produced that top layer. Then after that, that flood occurred, and it carved it out. So we see vertical layers, vertical walls, layers of vertical walls, multiple layers and so on, all happening within hours. So Nicholas Steno was right. You don't know exactly how long between each layer took. In this case, not very long at all. So therefore, by the way, when you look at that, there's a picture of the like the fine layers that got produced in that whole middle layer that's 25 feet thick. Just one quick one then too. How about some redeposited rock? There is from Mount St. Helens, where it chewed up rock and then relayered it. You look at that picture. Mount St. Helens. Didn't take millions of years, didn't even take thousands of years, didn't take hundreds of years. And that is very similar, isn't it, to that picture, which is Grand Canyon. Water can do a lot. This is a picture of the Glen Canyon Dam spillway damage in 1983, when they had to let more water through the tubes because they were worried about flooding and breaking the whole dam. And that water, they heard rumbling in one of the turbine channels. And those guys are standing down there. You can see the size of them. This carved this in just days, like not even a day. Because when water moves quick, it cavitates and it just breaks apart things very, very quickly. So we see then lots and lots of activity can be done quickly in a short period of time, and maybe better accounts for things that we see today on the land surfaces. So 1 Peter chapter 3 verse 15. Sanctify Christ as Lord in your heart, always being ready to make a defense to everyone who asks you to give an account for the hope that's in you. Do it with gentleness and reverence, right? So when we do these things, we are trying to say, no, you're not going to know all this. I don't even know it all if I don't have the PowerPoint in front of me, type of thing. So therefore, but you know the ideas more and more. And you can start to say, well, no, it happened quickly with a lot of water. You know, like there's guys that do this, and you can then say, oh, go to creation.com. Look it up. And you see, you can sort of at least try to help people to go through some stumbling blocks, especially with people backgrounds in science and so on, that have stumbling blocks to coming to faith. And it's things like this. That's why I won't get into that one. Universities are a hotbed for causing us to walk away from what faith we may have had as young people. So I'd like to thank you for putting through this a little longer. And who knows, you may see me again. I don't know. I'll try not to geology again or something. I don't know. Try something different. So thank you very much. Okay, thank you.